Okay, here we go. Um, so we want to take an area bounded beneath the curve f of x equals sine of x and the x-axis over the interval 0 to pi. And we want to construct 100 rectangles and find the right-hand sum, the left-hand sum, the midpoint sum, and the trapezoidal sum. Sounds ridiculous, doesn't it? But we're going to do it because we're really, really smart. Do you remember what the graph of sine of x looks like? It's a wave. Do you remember what the period is? 2 pi. So therefore, the first half is just pi, correct? So the sine graph for the first half of it would just look like that. Yes, I expect you to know that on your own. I'm sorry. What's the width of the entire interval? Pi. So if there's 100 rectangles, what would be the width of each rectangle? Right. So the width of each rectangle is equal to pi over 100. So here's what we want to do is we want to be able to really figure out, where we evaluate these heights. So like the first rectangle would be from 0 to pi over 100, right? And then what would the next one be? 2 pi over 100. What would the next one be? 3 pi over 100. Now, we can't really do all of those, can we? How about this? What would not the last one, not the next to the last one, but the second to the last one, what would that one be? 98 pi over 100, and then 99 pi over 100. Real good with that? Eyeball, you got a question? Oh, okay. Is that a nickname? Does everybody know that? Most people? Okay, all right. I like it. Here's what we're going to do. Is you realize that our formula for finding these areas when the width is the same is take the width times the sum of the heights. And there's a formula that we can plug in our calculator that we evaluate those for us. Do it rather quickly. What we do is we type in this. The width times sum of the sequence of y sub 1, comma, x, comma, first, comma, last, comma, width, double parentheses. As soon as you want to complain about the formula, I will offer you the opportunity to add it up by hand. Any takers? No takers. Very good. So, take out your calculator. Let's do it. I'm going to do r sub 100. Okay? And if I do r sub 100, what's the width? So I do pi over 100. So I go to my calculator, get rid of that graph, and I go pi divided by 100. You must stop me if you don't follow. Is everybody good so far? Okay, second thing I do, sum. How do I grab sum? I go to catalog. Catalog is right where the 0 is, second 0. That brings me a catalog of all the operations you can input to your calculator. And I press C for catalog. It'll bring me to the C's. And I go down and I find the one that says, wait a minute, no, not C, S for sum. Sorry, I was thinking catalog. I'm an idiot. Thank you. Appreciate your understanding my mistakes. And there's sum. Cool. Actually, I think if instead of pressing S, if you press T and then go up, ooh, there it is. That'll be really quick. Yeah. Sum. I don't know. I don't know everything about it. Now what? Sequence. What do you think I press? Catalog. Then S. Sequence. We're going to do the sequence with the parenthesis after it. Good. Then what? Y1. Now, if you would like to, you could just type the function. So I'm going to show you both ways, okay? You ready for both ways? So if I go into y equals, oh, look at what I have there. I already have it there. So if I go into y equals, I type in sine of x. Then in my work here, that's my y1 variable. And the way you access the y1 variable is you press vars for variables. I showed you how to do this one day. And I'm grabbing the y variables. And I'm using the function y sub 1. Got it? Or instead of y sub 1, you could just put in sine of x. Make sure you close the parentheses. Comma. Comma is right above the 7. Now what? X. That's my x, comma. Everybody with me? First, what is the first spot for the right-hand sum that we evaluate the heights? This is where the math really comes in. Look at the drawing. Pi over 100. So we do pi divided by 100, comma. You're going to have to do this on your test, by the way. Okay. This is absolutely necessary. Now, the last spot. Where's the last spot we evaluate the height? Pi. So I go pi. Then we need the actual width of each interval. What's the width of each interval? Yeah. And double parenthesis. Now, before we press enter, I just want to show you guys what the heck your calculator is doing. So you all understand. Notice what we were trying to say is the width times the sum of the heights, right? So the width is pi over 100. We got that? Sum of the heights. That's the sum. Okay. Where do we evaluate the heights? Well, we evaluate the heights at pi over 100, and then we move forward pi over 100, right? To 2 pi over 100, then to 3 pi over 100. So this tells me how much I move over each time. When do I stop moving over? When I get to pi. Where do I plug these all into? I plug them into y sub 1. So the sequence thing tells me to start at pi over 100 and move over pi 100 over 100 units until I get to pi. So that's what we've told our calculator to do. Okay, start doing it here, then go here, 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 yada, 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 and add them all up, sum. That's what we've told our calculator to do, which is really cool. So we go ahead and we take this guy and we press enter. And it takes a while for your calculator to think, especially if it's TI-83, because it's not as smart. I go, what? You got an error? You did it wrong. You should get 1.9998. I'm going to pause right now and check to see those people who did not get it, what went wrong with their calculator. we saw that the right-hand sum came out to be 1.9983. What do you think the actual sum is? It is. It's 2. Works out exactly to 2. Now, I'm going to show you how to do the next part easy. Don't press anything on your calculator. Okay? Let's do the left hand of 100. We would do pi over 100 times the sum of the sequence y sub 1, comma, x, comma, what would be the first spot I evaluate the height? 0. What would be the last spot I evaluate the height? 99 pi over 100. What's the width of each interval? Still pi over 100. That doesn't change, does it? Okay, so right now you're having a little anxiety about how you have to go into your calculator, you got to type in sum and sequence and y and all that stuff, right? So don't worry about it. Just go second entry, and it pulls that exact same formula you just had. And I could go back into there, and I could change my first one. I just now mess up this portion here. I go 0, comma, and I do 99 pi over 100, comma, pi over 100. So that saved me a lot of time, didn't it? Oh, got an extra parenthesis. Thank you. I press enter, and it takes a while to think about it. And I've got 1.99884. I'll tell you how many decimal places I would like on the test. But, usually, 3 decimal places is pretty good. I'm trying to go further here just because, otherwise they all start to look the same at 1.99. So let's do the midpoint. Huh. What's that spot right there? Pi over 200. Does everybody see that? So I start at pi over 200. So what would be my last spot? 199 pi over 200. And if you're ever wondering, folks, just add them and divide by 2. So if you look at that set right there, pi plus 99 pi over 100 and divide by 2. That's what the true midpoint formula is. Watch what happens. We find common denominators by multiplying top and bottom by 100. Is everybody convinced now by looking at that you're going to get 199 pi over 200? We all good? So let's write out what we're going to enter. We enter pi over 100 times the sum times the sequence of y1, comma, x, comma, pi over 200, comma, 99 pi over 200, comma, what's my width? But we're doing the midpoint, so it switches to, very good. Yep, I'm trying to trick you. You get that? Tamara's looking at me. The width always stays the same. Look. Oh, 199. Yeah, sorry. I jumped ahead. Got what's up? What? All right, so we're going to take that entry, and we're going to go back in, and we don't start at 0. We start at pi divided by 200, comma, we go to 199 pi divided by 200, and then we tell it the width is pi divided by 100. Alex got 0. That's wrong. I press enter. My calculator has to think for a long time because this is super difficult to do. And I get 1.99958. Cool. We have one more to do, and that is the trapezoidal sum. Were our widths the same? Yes, they were. All we need to do is just average the left hand and the right hand. Right hand sub 100 plus left hand 100 divided by 2. That's all we need to do. 1.99983 plus 1.99884. Enter divided by 2, and I get 1.999335. So it's teaching you how to move from left to right to midpoint. You're still doing all the work, aren't you? You're just coming up with a more exact answer. Finally, the last thing I will do is I will second calculate number 7 to try to find the exact area bounded from 0 to pi. And what I do is I type in 0, and my upper limit is pi. And it calculates it. Dos, which is Spanish for 2. Kind of cool, huh? Now, folks, I'm going to tell you on Monday how to do that exactly without using your calculator. And it's not going to be quick. No. Oh yeah. Yep. And you'll be good at it. Like I'll teach you how. This is almost a no calculator test. All right. Finish up your assignment.